Alright, so today is all about 6.4. The title is Properties of Rhombuses, Rectangles, and Squares. I'm assuming you already know a lot about rectangles and squares. The new one might be a rhombus. You've probably heard of it before, but we'll dive a little deeper into all three of them today. So our objective is to use the properties of special parallelograms. Any questions before we get going? Alright, here is everything you need to know about a rhombus. So I'll give you a couple minutes to write this down, then we'll discuss it. Go ahead and draw this picture down here. We're going to add some things as we go to make sure that we're showing all of these important things on this rhombus. Just make sure you get all of this down. Leave yourself some space to add some things to that diagram. So the definition of a rhombus is a parallelogram. So all the things that we know about a parallelogram that are true for a rhombus as well. But the only important special thing here is that all these sides are congruent. So all four sides are the same. So you can go ahead and label that in your diagram. Mark them all the same. Now when that is the case, a few other special things happen as well. Each diagonal bisects a pair of opposite angles. So let's add some diagonals. Now, since it was a parallelogram, the opposite angles were congruent to begin with, but now each of those angles is bisected. So label those angles as being congruent, and then they'd also be congruent to these angles down here as well. Same thing for the other diagonal. You can add it in, and then these are going to be congruent as well. They're bisecting those angles. So that's one important thing that happens. The other important thing that happens is each diagonal is a perpendicular bisector of the other. Perpendicular bisectors form right angles. So all of these angles in here are right angles. And then it also gives us some congruent segments. These cut each other in half, just like any other parallelogram. So the important thing with the rhombus is the right angle part. The bisector part has already been true. So lots of information on that diagram. Do you guys have any questions about what any of that means? Alright, the next special parallelogram we're going to look at is a rectangle. Again, just take some time to write this down. And then we'll add some information to that diagram as we go. So the definition of a rectangle is a parallelogram with four right angles. So what makes this one special is that all of these angles are right angles. And remember, all the other properties of a parallelogram are still true. So opposite sides are still congruent. And of course, all the angles are congruent. And then the other neat thing about this is that the diagonals are congruent. They also bisect each other just like any other parallelogram, but they're congruent here as well. So the definition for a square, it's a parallelogram, so everything you know that's true about parallelograms is also true for squares. And a rectangle and a rhombus. So everything you know about rectangles is true, everything you know about rhombuses is true. So it has four congruent sides and four right angles. So let's go ahead and label those. So all the angles are right. And all the sides are congruent. The other thing that is cool here is with your diagonals. The diagonals, since it's a rhombus, they actually bisect the angles. Since it's a rectangle, they're congruent to one another. And again, remember with the rhombus, they form right angles, so these are all going to be right angles. So all those cool diagonal properties are going to hold true. It actually creates 4 congruent isosceles triangles. So this triangle is congruent to this triangle, congruent to this triangle, congruent to this triangle. And that is unique to a square. What are your questions here? So the rest of the lesson is just going to be looking at examples where we're taking these properties and we're applying them to some problems. So there's multiple ways you can do that. Some of them you're solving equations, some of you are just picking out lengths of segments and stuff. So let's take a look. Alright, here's example 1. So I'll give you a second to write this down. We have a rhombus. As you're drawing this picture, think about the key features of a rhombus, particularly the sides, since we're looking for all the side lengths. So what's true about the side lengths of a rhombus? They're congruent. So what is the measure of every single side in this rhombus? 10.5. So this one's 10.5, this one's 10.5, and this one's 10.5. Now, you can label them the way I just did, so sort of like a fill-in-the-blank way. Or if you want to label them right on the diagram, you can too. If you're going to label in the diagram, though, make sure you circle your answers. That will draw our attention to the fact that that's your answer and not just some doodling you're doing to help yourself. So either one is fine when answering this type of question. Any questions about rhombus TUVW? So as you're drawing this rectangle QRST, remember all those things you wrote about rectangles. What's so special about the angles of a rectangle? All the angles are congruent. More specifically, all the angles are in your notes, we labeled them with a little box. They're all what? Right angles. What's the measure of a right angle? 90 degrees. So angle Q is going to be 90 degrees. So is angle T, so is angle R, so is angle S. The next thing we're looking for is the length of this segment, TS. Since it's a parallelogram, it's the same as the opposite side, so it is 7. Good. And QT is 2. Very good. I'll give you a second to catch up. Anyone have any questions? All right, and here's the last one I'm going to require you to write in your notes. We are still going to look at 4 more examples, but I just want you to have these basic 3 in your notes. So now we're talking about a square. So everything you know about a parallelogram is true, everything you know about a rhombus is true, everything you know about a rectangle is true. What's the measure of all the angles of a square? Just like a rectangle, they're all 90 degrees. So the measure of angle C is 90 degrees. And just like a rhombus, what's special about all the sides? They're all the angles are right. All the sides are congruent. So what are all the sides of this square going to be? 6. So you can fill this one in as 6, this one in as 6. Again, if you would prefer to just do it on your diagram, that's fine. You can label BC 6, you can label CD 6, and you can label angle C 90 degrees, whichever method you prefer for delivering your answer. Any questions? Alright, we're going to look at 4 more examples. Since we are on a shortened schedule, though, I'm not going to require you to put these in your notes. You can if you want to. It's up to you. But these are the 3 that you definitely must have in your notes. Here's just a little extra. So, number 4, it says to find the value of x in rhombus A, B, C, D. So, we are given information about this angle right here, CPD. Now that's an angle where the bisectors, where the diagonals intersect one another, correct? Did you learn anything about the angle formed by the diagonals of a rhombus? Look back in your notes if you're unsure. In a rhombus, the diagonals are perpendicular. What does it mean to be perpendicular? They form what kind of angles? Right angles. So all of these angles are right angles. So we can set 5x equal to what? What's the measure of a right angle? 90. And then we can solve for x. How do I solve for x? Divide both sides by 5. That gives us 18. Very good. So again, everything we're doing today is just relating back to those properties you wrote down. So figure out what you're talking about. We're talking about a rhombus. Go to that section of your notes. Read through everything that's true and see which one applies to the problem you're working on. Any questions? Alright, here's number 5. Now we're talking about a rectangle. And I'm given some information about angle K. What do I know about angle K if this is a rectangle? It's a right angle, so I can set 2x plus 10 equal to what? 90. And then I solve for x. So I'm going to subtract the 10 from both sides. So 2x equals 80. And then what's x going to equal? 40. Very good. What questions do you guys have for example 5? All right, next we have example 6. We're given that this is a rhombus, and we're given some information about 2 of the sides. Well, what is important about the sides of a rhombus? They're congruent. So set those expressions equal to one another and solve for your x. How would I solve this? I have x's on both sides of that equal sign. If you subtracted 7x, you'd have nothing over here. You don't want to have nothing. So you can subtract the 5x. Good. So 7x minus 5x, that gives me 2x equals 4. And then what? Divide both sides by 2. So x is going to equal 2. What are your questions? All right, one more to look at for today. We have a rectangle. We are given some information about EG. So that's this guy right here. And HF, this guy right here. So we know a little bit of information about each one of the diagonals. Well, what's special about the diagonals of a rectangle? If you're unsure, go to the rectangle section of your notes and read me the part that has the word diagonals in it. Congruent. So I can do what with these two expressions? Congruent is the same as you're going to end up dividing. Congruent means the same. The same in math means equal. So you can set these equal to one another. And then you can get the x by itself using division. So x is going to be 8. Very good. So again, these are all special parallelograms. So everything you know that's true about a parallelogram is true for a rhombus, a rectangle, and a square. Rhombus, all the sides are the same. Rectangle, all the angles are 90 degrees. And then a square has both. So all the sides are the same and all the angles are 90 degrees. You guys do have homework tonight. I'll get you that in 1 second. But any questions first?